Welcome to my YouTube channel Modi Mechanical Engineering Tutorials. In this video I would like to explaining in detail study about two metals completely soluble into liquid state and completely insoluble into the solid state. So it will be nothing but it will be known as a eutectic type of transformation of both the metals from liquid state to solid state. So first of all, let's take two metals. Metal A, which will be having a melting point at 1500 degree centigrade, and metal B, which will be having a melting point is 1200 degree centigrade. Let me take a eutectic composition. So eutectic compositions around 60% of A, 40% of B, and at a temperature, and that will be known as a eutectic temperature. So it will be around 1000 degree centigrade. Now according to the eutectic type transformation means our liquid phase that will be transforming into the two different solids, and that will be solid 1 plus solid 2. But which conditions? So this liquid, it will be transforming into two solids. It will be at eutectic temperature and eutectic composition. So at specific temperature, or you can say eutectic temperature and eutectic compositions, so this 100% liquid phase that will be converting into two different solids. So this will be only happening by the cooling. And if you heat these two phases of the solid materials, so once again it will be converting into the liquid phase. So these two solids, it will be making two different phases into the solid state conditions. So that's why it will be known as two metals completely soluble into liquid state but completely insoluble into solid states. So now I will start to draw a phase diagram for the metal A and B with the given conditions of 60% A as a eutectic compositions and 1000 degree centigrade as a eutectic temperature. So let's see. So according to the given data, just you can make a x-axis and y-axis. So x-axis it will be for a weight percentage of composition. So let's take different points onto the x-axis. So starting with the weight percentage of A and weight percentage of B. Onto the left side 100% A, 0% B. Then I will take different points like 80-20, 60-40, 40-60, 20-80 and 0-100. So just you can see from both the ends. So left hand it will be the 100% A metal and right hand it will be the 100% of B metal. Now according to the given temperature range of the metal A and B, I would like to take different points for the y-axis. So this axis it will be representation as a temperature in degree centigrades, and let's take different points 500, 1000, 1500 and 2000 degree centigrades. Similarly, so starting with a metal A which will be having a 1500 degree centigrades. So let's take onto the left side. So here it will be 100% A. So 100% A, or you can say that it will be act as a pure metal. So in case of the solidification of pure metal, which will be having a same melting point and freezing points. So according to the metal A, which will be having a 1500 degree centigrades. So this is the point. Similarly for metal B, which will be having a melting point around 1200. So I think it will be almost here. 1200 degree centigrade. So these 2 points, it will be from a melting point of A and melting point of B. So right now both the metals, it will be act as a pure metal. So that will be having the same melting point and freezing point. Now for the third point, or you can say eutectic points, so it will be the given conditions, just you can see. So the eutectic compositions, and that will be 60% A and 40% B. So just you can take a point which will be having a 60% A, so this point, and 40% B. So just you can make a mark over here for the eutectic compositions. So eutectic compositions. Now according to the temperature range, or you can say eutectic temperature, so that will be 1000 degree centigrade. So this point, so it will be known as a eutectic temperature. So just you make a one horizontal line from the eutectic temperature and one vertical line from the eutectic compositions. So by the making one horizontal line and one vertical line, so it will be intersecting at this point. So this point is known as a eutectic point. So generally the eutectic point, that will be the intersecting point of the eutectic composition and eutectic temperature line. So according to the different cooling curves from the pure metal, eutectic binary alloy and off eutectic binary metal alloys, so it will be these points of like a P point, this point is Q, and this point it will be known as a R. So I would like to join P, Q and R. So this line P, Q and R, the above portion of all the compositions, it will be the formation of 100% liquid, because two metals completely soluble into liquid phase. So this line is known as a liquidous line. And just you can concentrate this line P, suppose this point it will be S, then Q, this point is known as a T point, and R. So P, S, Q, T, R. So this line is known as a solidus line. So according to the solidus line, the below portion of all their compositions, it will be the formation of the two different solids according to the eutectic type of solidification process, because both the metals which will be completely insoluble into solid states. So just you can note down this line, it will be known as a solidus line. So which will be forms a 100% solid, but it will be forms two different solid like S1 and S2. Now I would like to explaining about the eutectic transformations. So just you can make a one vertical line which will be passing through the eutectic points. So just you can see. So just you can make different points. So here it will be A point intersecting at the Q, and just below of the eutectic point, or you can say at room temperature, it will be makes a B points. So I would like to make a microstructural view at the different point for the eutectic systems. So this transformation from the liquid phase to solid phase, generally it will be passing through the eutectic points. So it will be known as a eutectic transformation. Now I will make a microstructural view for the different points of A, Q and B. So let us see. So just you can see for a point A. So A point is above the eutectic temperature line. So it will be forms a completely soluble liquid state, or you can say 100% liquid of metal A and metal B. So here, so at point A it will be the 100% liquid, and it will be having a compositions around 60% A and 40% B. Now I would like to make a microstructural view for the point Q. So point Q, according to the eutectic transformation line, our liquid phase that will be transforming into two different solids at eutectic temperature and eutectic compositions. So just you can see it will be makes 100% solid. So just you can see at just around point Q, so that will be the eutectic point. So all the 100% of the liquid which will be converting into 100% of the solid, but it will be forms of two different solids. So this orange color, it will be as a S1, and green that will be S2, with the composition of 60% of A and 40% of B. Now after the Q point up to the room temperature, so at point number B, or you can say around room temperature, once again it will be just rearrangement of the structure into the room temperature. So just you can make a microstructure for the point B. Let's see. So just you can see that will be for S1, this one is your S2 at room temperature. So according to the definition of the eutectic transformation, 100% liquid that will be converting into two different solids. So at room temperature, or you can say just below the eutectic temperature line, it always forms a two different solid phase, because both the metal that will be completely insoluble into liquid state. So this is a case number 1 with eutectic transformation. Now I would like to explain about before the eutectic transformation line. So now just you can take any composition point before the eutectic composition line. So just you can see I would like to take 80% of A and 20% of B and make one line. So this line is intersecting with the different points, like onto the liquidus line, onto solidus line. So as we already discussing above all the portions of the liquidus lines, so it will be forms 100% liquid. So just you can take points like X over here. Onto the liquidus lines there will be the Y. Onto the solidus line it will be Z, and onto the room temperature that would be Z dash. So as we know, by the transformation from the higher temperature to the room temperature, first that will be the intersecting at the liquidus line. So we all know each touches the liquidus line, that's why it will be the starting point of the solidification process. And onto the eutectic temperature line, so that will be the constant temperature solidification process. So in between Y and Z, it will be the formation of liquid plus solid 1. Why solid 1? Because S1 that will be refers to a solid phase of metal A, and Ya because here there will be the majority of the A metal, it will be into the this side. So this side, or you can say any point before the eutectic compositions, it will be known as a hypoeutectic transformation. So in the case of the hypoeutectic transformation, the majority of the A metal which will be having a higher side, so it will be forms a liquid plus solid 1, and that solid 1 it will be from metal A. Similarly, I would like to take a one point after the eutectic compositions. So just you can take a point around 20% of A and 80% of B, these points. So similarly, I would like to make a one transformation line from higher temperature to the lower temperature. So look like this. So this is a one point, or you can say X dash point, intersecting at the liquidus line, that will be the Y dash. Similarly onto the solidus line, Z double dash, because Z dash is already here, and at room temperature that will be the Z1 dash. So this is our case number 3. So one line that will be drawn before the eutectic transformation line, that will be known as a hypoeutectic transformation. The transformation line which is passing from the eutectic point, so that will be known as a eutectic transformation line. If you want to take any compositions after the eutectic compositions, likewise this, you can take any one from the any compositions after the eutectic compositions. So here that will be the 20% A and 80% B. So after this it will be known as a hypereutectic. So similarly, just above the liquidus line, it will be forms of 100% liquid. Once it touches the liquidus line, so it will be the starting point of the solidification process. But this solidification process, it will be occurs from after the eutectic composition line. So that will be the formation of liquid plus solid 2. So S2 means it will be the solid phase refers to the metal B, because after this eutectic composition line, the majority from the metal B. So this S2, it will be refers to the metal B. And after the solidification process, or you can say just below say eutectic temperature line, it forms two different solids. So here that will be the solid 1 plus solid 2. And similarly for hypereutectic transformations, it will be forms of solid 1 plus solid 2. So if you want to take any compositions which will be having a solubility into the liquid state but completely insoluble into solid state, so just below of the eutectic temperature line, it always forms two different solids. Now I would like to draw a microstructure view from the different points onto the hypoeutectic transformation and hypereutectic transformation lines. Now I would like to explaining about the microstructure for the case number 2, and that will be considering as a hypoeutectic transformation, because that will be occurs before the eutectic compositions. So at point X, that will be representing just above the liquidus lines. So according to the definition of the liquidus lines, it forms the 100% liquid of A and B. So it will be makes a 100% liquid which will be having a 100% solubility. So the microstructure is look like as we discussing in the case of the eutectic transformation, but in that case that will be having a different compositions. So compositions, it will be 80% A and 20% of B. So here I will start to draw a microstructure at point Y. So this point. So once it will be touched the liquidus line, so it will be the starting point of the solidification process. So at point Y, what happened? Just it will be making a small tiny particles. So these particles, it will be from S1. So which elements that will be having a majority, it will be the starting point of the solidification process. So from this side, it will be the A metal which will be having a majority. So almost 80% A is being used to make a compositions. So here it will be the solid tiny particles, or you can say that will be known as a nuclei. So this nuclei that will be from metal A, and rest of the others from A also and from B metal also, it will be in the form of liquid. So just you can see. After this point, I would like to make a microstructure view at a room temperature, or you can say at Z dash points. So we already study into the eutectic points. So into the eutectic, just below it always forms two different solids, and at a room temperature it will be the rearrangement of the microstructure. So just you can see. So from the microstructure for 80% A and 20% B, so this orange that will be S1 and green it will be indication as a S2. So here the weight percentage like 80% of A and 20% of B. So the majority it will be the solid phase that will be from metal A, so which will be representing as S1, and only 20% of the S2 because that will be the 20% of metal B. Now similarly for the hyper-eutectic, or you can say case 3. So in that case, similarly for X dash points, it will be just above the liquidus line, so it will be always forms 100% liquid. So we already discussing into the eutectic transformation. So in case of the hyper-eutectic, it will be having a 20% of A and 80% of B metal, but it always makes 100% liquid. So when the transformation line which is touches the liquidus line, so that will be the starting point of the solidification process. So let's see, it will be the formation of a nuclei, and this nuclei that will be basically for the majority of the metal. So here that will be the majority for the metal B because 80% of B when 20% of A. So in this side it will be the formation of the tiny particles from metal B. So just you can note down, this is our nuclei and which is from metal B. So in previous case, just you memorize, for the nuclei it will be from metal A, and for the hyper-eutectic it will be from B, and rest of the part it will be into the liquid for B as well as for the metal A. So which will be having a compositions around 20% of A with 80% of B. Now I would like to interest to draw a microstructure at Z1 dash point, or you can say around the room temperatures. So that will be making a finer particles because below any compositions from the eutectic temperature lines it will be forms of two different solids. Just you can see. So just you can see from another end, you can say in the case of hyper-eutectics, so these green colors that will be S2. So that will be having a majority as compared to S1. So this orange that will be indication as a S1. But in simple way, for any compositions for these metals which will be having a totally insoluble into solid states. Now I would like to find out various percentage of the liquid and solid with the different conditions for the hypoeutectic and hyper-eutectic. So just you can make a point which will be similar as 80% of A and 20% of B, and around the temperature range of 1100. So just you can make a point. So that will be 1100. So according to this temperature range, I would like to draw a one horizontal line which will be like this. So by making one horizontal line which will be intersecting the solidus line, composition line and liquidus line. So this it will be M, N, O. So this line it will be known as a tie line. So So tie line is nothing but which will be a horizontal line from a temperature which will be intersecting the solidus line, composition line and liquidus line. So now I want to know how much percentage of the solid is being formed at these conditions, or you can say around 1100 degree centigrade for the composition of 80% of A and 20% of B, or you can say around point N. So this will be found with the help of lever arm rule. So if you want to learn in details for the lever arm rule, you will find a link in my description box. So right now just you can make a projections from the intersecting of the solidus line, composition line and liquidus line. So for the solidus lines it will be 0% B, here 20% B, and just you can make a projections from the O point onto the composition lines. So like this. So I think it will be around 30% of B. So every time I will take a reference from the percentage of B. So according to the lever arm rule, just you can see weight percentage of liquid. So just you can make a side of intersecting with the solidus line. So here that will be the point M. So this point it will be intersecting onto the solidus line. So just you can take a distance M to N. So M N divided by total length MO into 100. So Mn means that will be 20 minus 0 divided by 30 minus 0 into 100. So around 66.67% of liquid. And now I would like to calculate the weight percentage of A. Weight percentage of pro-eutectic A. So that will be reverse side. So it will be touches the liquidus line. So intersecting liquidus lines at O. So NO divided by MO into 100. So just you can make a difference like 30 minus 20 divided by 30 minus 0 into 100. So 33.33% of A. So at point N, or you can say these compositions like 80% A and 20% B and a temperature around 1100. So only 33.33% of A that will be converting into solid phase, and rest of the other 66.67% in the form of liquid. So similarly you would also find for the same compositions for the hyper-eutectic like 20% of A and 80% of B. So just you can make a one composition line from this and temperature lines onto the same as a 1100, and you should take any temperature line which will be passing through the solidus line, composition line and liquidus line. So here like this. So that will be M dash, N dash and O dash. So similarly you will also find a weight percentage of the liquid as well as the weight percentage of the pro-eutectic for B. Right? So these all are the fundamental knowledge about the solubility for the both the metals, which will be having a 100% into liquid and 100% insoluble into solid state. Suppose I want to draw a cooling curve for the all three cases. So just you can see for the case number 1. So that will be the eutectic transformation. So just you can see. So this is a liquid because above from the liquidus lines and in the region between the eutectic composition line. So here that will be the liquid plus solid 1 plus solid 2, and just below the eutectic compositional temperature line, it will be forms S1 plus S2. So this is a cooling curve for the eutectic transformation. Suppose I want to draw a cooling curve for the hypoeutectic. So it will be look like this. So here that will be the liquid. In between this point, liquid plus solid 1, and here that will be the liquid plus solid 1 plus solid 2, and after this it forms S1 plus S2. Suppose I want to draw a cooling curve for the hypereutectic. So just you can see. So here it will be the 100% liquid. In between liquid plus solid, so this solid 2, it will be from the metal B, and in between these two, that will be once again liquid plus solid 1 plus solid 2, and just below the eutectic temperature line, it forms S1 plus S2. So this is all about a eutectic type of transformation. So in that case, liquid phase that will be converting into two solids at the specified compositions, or that will be the eutectic compositions and eutectic temperature into two different solids. So I hope you understand for the general metal A and B. So if you like this, then subscribe and share more the mechanical engineering tutorials. Thank you so much and keep watching.